The Data Hot Seat. Hello, data friends. Welcome back to the Data Hot Seat, where we keep chipping away at the big announcements from the Databricks Data and AI Summit, one topic at a time. I'm your host, Paul McComish from Advancing Analytics, where the coffee is still strong and the dashboards are, as ever, a work of art. Today, we're talking about two things that go hand in hand, Lakehouse RT and LTAP. Lakehouse RT is Databricks' big claim that the best real-time warehouse is now a lakehouse. Millisecond performance directly on your existing Lakehouse tables, no copies, no extra pipelines. And LTAP, Lake Transactional and Analytical Processing, is the broader idea that your lake should be able to handle both your operational and your analytical workloads without needing separate systems bolted on the side. If you ever built a pipeline whose entire job was just to move data into a separate real-time database, this episode is for you. I'm speaking to Peter Sach from Advancing Analytics, who will help us to delve into the details. So let's get into it. Okay, welcome to the hot seat to Peter. Hi, Peter.
Hey, Paul. How's it going?
Not too bad. How are you?
Yeah, good. Good. Busy day.
It's always busy. Always busy here at Advancing Analytics. For those who don't know you, who are you? What do you do?
Yeah, principal here at Advancing, principal data engineer, which means that I spend basically my entire life in Databricks and sort of work around helping our clients with their management and understanding of all the new features that Databricks brings its way. Therefore, I've been watching the Data and AI Summit with a keen eye and excited to talk about some of the new features today.
Awesome. Well, obviously, the topic for today is all about the Lakehouse RT, Reyden, and LTAP, all those sorts of things. So we'll start off with Lakehouse RT. It's positioning itself as the best real-time warehouse that is now in a lakehouse. So for anyone who hasn't actually seen that announcement, what is Lakehouse RT? What problem is it actually solving?
Lakehouse RT is solving a problem with having to replicate your data to achieve low latency at scale. So at present, you'd be pushing your data, you do all your work in Databricks and you push it out to Pinot or Druid, and you'd be storing it again separately just to achieve the scale that you need for high concurrency sort of reporting. So when you're a large organization, you've got many users, they're all hitting the same Databricks cluster, then you need to be using a new compute engine with lower overhead, and that's what Lakehouse RT is bringing you. So the real value we're unlocking is the ability to scale without having degradation as we get more users and maybe even agents on the platform.
So we saw in the announcement that this thing looks really, really fast.
Mhm.
So just as an example, if I'm streaming data in really, really fast, at the moment I might get, if I'm lucky, a low latency of maybe a few seconds. Now, that might not be too bad, but what you're saying is this is even faster?
Yes, yeah, we've seen huge speed ups down to, for the smallest queries, milliseconds, and then hundreds of milliseconds for large queries. So we're really cutting out the overhead that we have with queries with Lakehouse RT. Yeah, to get our hands on it itself, it's in beta and it's only read only, even once you do get your hands on it at present. That will change over time, but we really expect to see the claims that Databricks have made with some really impressive benchmarking replicated in our customers' hands when we get there.
So what sort of customer do you typically see would want to use this? It's obviously not your really, really small company that only need to do like a
For
daily
sure.
batch reporting. So what sort of what sort of clients, what sort of companies have you seen that this would be really beneficial for?
Yeah, definitely large scale enterprise where we're doing a lot of analytics. We need that high concurrency, lots of reads on our data, and we need to have that consistency where they may already have this replication in place. What we're doing is simplifying their entire overall infrastructure. We're bringing it back down so they're just using Databricks. They don't have to focus on replication pipelines. They don't have to enforce governance that's already in Unity Catalog into a new DB. They can just use Databricks and have a simple overall architecture with less overhead and management of their data lake.
And if we just expand on that a bit, so the typical examples that you see at the moment is we're having to replicate this data into another sort of system, right?
Yes, yeah, for sure.
So just in terms of like latency, we're obviously looking at faster reads, but if you've only got this data in one place, that means that that data is going to flow through to your reports much faster. So the latency is kind of like the key great thing of this. But there's a cost implication to this as well. We're just running, you're not running two systems.
For sure, for sure. The direct cost of not spinning up a system itself, and then the overhead of having to manage extra skill sets for those systems, extra pipelines to replicate to those systems. Really, it's a cost benefit, a security benefit. It's really a win all round by having Lakehouse RT as another option within the Databricks platform.
And we saw the underlying of Lakehouse RT is this thing called Reyden. Now,
Mm.
again, for those who didn't see the announcements or didn't see any of the keynote, why is it called Reyden?
Um, so Reyden stands for Reynolds Dream Engine, and one of the founders, Reynolds Jin from Databricks, has been leading this rewrite of the overall engine in order we can get this more increased performance, increased speed, lower latency across the overall platform. It's what powers Lakehouse RT is that we have this Reyden engine that backs everything up, and it's a complete overhaul of the internals of how the Databricks engine runs. And whilst it won't mean much in terms of how you write the code, you're writing your same code, you're still using Spark. It means under the hood, you're just getting so much more performance. And it's been really impressive when we've seen sort of some of the benchmarks that Databricks have put out, certainly as they scale, but certainly the ones that I found impressive, but like how well it did with some of the harder benchmarks we have out there, where other competitors and also Databricks' previous engines were crashing. This was handling it with ease.
And if a client came to you tomorrow, let's just assume that Lakehouse RT is already
For sure, for
generally
sure.
available. If a client came out to you tomorrow and they said they were interested in it, what would be the first questions you'd ask to figure out whether it's the right fit for them for where they are right now?
It's understanding their profile. If they already have this profile where they're writing to a new DB, they're performing high concurrent reads from their Lakehouse, they're a perfect fit for Lakehouse RT and therefore the Reyden engine. If they aren't, then they can stick with what Databricks has already and does great. We've got Photon for vectorized queries if they need that extra performance for like large, complicated reads of files. So it really depends on the scale more than anything for which customers I think would be using the Reyden engine. It's key when deciding to use these things that we don't bring them in because they're the hot new thing, that we go, is this right for this customer? Because every feature you add in an architecture for a customer can complicate the message. And what you want is to have a clean message. And this really is a clean story. If it's you need high concurrent reads, we're saying you've got this one feature, Lakehouse RT. We don't need to spin out Pinot or Druid. And the client at that scale will be very aware of Pinot and Druid and Redis and ClickHouse and others, because they will have to have had that to solve the problem in the past. So it's really about matching the feature set to the customer and ensuring that our customers understand these features and that we propose them only when necessary. But it seems like in lots of cases, this will give us an option where there previously wasn't one.
It's really good, isn't it? And it comes back to something that I was talking with Terry about on the first episode, and is making sure we don't follow the, chase the shiny tools, the shiny toolitis, as I called it. So it is a case of making sure that we've got the right tools for the job, and not just because it is a shiny thing that we should just instantly put that in.
For sure, for sure. And at the Data and AI Summit, there was lots of shiny tools coming out, but
Always is.
there always is. And the shiny tools certainly, though, have a use. For each of these key announcements that we've been going through in these podcasts, there's definitely situations in which I could have used them at a customer, including this. So it's great to have the options. They're all very shiny and new, but like always, we suggest what's best for the customer based on what they need and what will solve their problem. And this just allows them to, again, have this one platform that's ever growing. That means that they can have a single sort of pane of glass on their data. And we've got all those sort of standardized access, security, cost monitoring all in place. And that really allows us to bring different teams together who may be working on the same data sets or similar problems, working alongside each other and being able to break down the walls between different teams working on similar problems because they share the same platform. Certainly a client I'm working on at present, like we have two different teams currently working in two different products. One's in EMR, one's in Databricks. We then have to organize the handoff, and that's a lot of overhead and management. What we should be doing instead is bringing everyone on the same platform, reduce that overhead, and we can really get something special out of people collaborating a lot closer. So it's very exciting to see all these tools. And by getting people to collaborate on the same platform and by having these extra options, we can bring everyone to the same platform because they've not got a reason to need to be off of Databricks.
Yep. Amen to that, I think.
Yes.
um, how do you think the competitors out there to Databricks are going to react to Reyden and Lakehouse RT? Do you think they will start to rebuild some of their functionality as well?
I think so. It's an exciting time, and certainly there's almost an arms race going on in data. There always is. So we'll see tools like Snowflake and others have to react to this as Databricks continues to like push the forefront in data. I saw a recent Gartner report came out, and they're still sitting in that top right hand corner. So they need to be competitors need to really push back, and certainly with like we're seeing with AI and other tools, it's needed to stay ahead of the game. Like it's very fast moving at the present. If you go to the Databricks release pages, you'll see new stuff every day. And that's just needed to make sure that you remain competitive. So it's pretty exciting. Even if you're with a competitor of Databricks at present, you'll probably start to see some of the great updates that we're seeing from Databricks replicated in your own products as well.
Yeah, the speed of these changes almost makes me nostalgic for the old days when, you used to have to wait for your updates to come through on a CD, and then for your
Yes.
IT teams to install it on the servers. Oh,
Every 2 years you get a new SQL Server version, and yeah, you can prep for it, and it would be great. But no, that's basically what we do is try and stay ahead of the curve. Part of the Databricks Champion program, which means that we get a bit of an inside peek. It's certainly hard, and certainly I spend a lot of time refreshing that platform updates page to see how we can stay ahead of the next new feature, next new tool.
makes me worried about going on holiday now. I'll come back and I'll be out of date.
Oh, I love going into Databricks and finding a new button that wasn't there before and having to figure out what it does.
Yeah.
Actually, like in general though, the previews pane, it's quite exciting to go in there. As these features roll out, you can sort of turn them on, get used to them. So it's a nice, easy adoption pathway for users who may want access to a new feature slightly before it's fully GA.
And it's really good, isn't it? You can try some of these features out before you necessarily have to put them into production. You really understand how they work.
Yeah, for sure. For sure.
So we were going to talk about LTAP as well. Before we delve into LTAP, because it's quite heavily linked into Lakebase, we probably should just do a quick recap on what Lakebase is.
Yeah. So Lakebase, fairly new product actually, but sort of been adopted quite heavily and been needed for both operational and AI use cases. Lakebase is Postgres, but managed by Databricks and sitting within your Databricks platform. It's Postgres front end that still stores your files in the cloud. So it's managed Postgres by Databricks, and that's really answering the problems that we have when we're doing OLTP workloads within Databricks. So that's transactional, row based, many rows in, many rows out. We don't actually want to do these big columnar aggregations that we do on the analytical side. And that's really key when we're doing AI projects where we need to feed in and out context and want to write loads and rows one after the other. It's really key when building some web apps. So I've been building a lot of Databricks apps recently. If I'm building a log or if I'm storing some sort of history, like I do just care about reading and writing individual rows. That kind of transactional nature has always been catered for. And row-based operations certainly need to have low latency for website operations need to have low latency to have a good user experience.
Yeah.
So when running a query in Databricks SQL is fine if it takes a couple of seconds to go through. If every time you went on Amazon, clicked a button, and it took a couple of seconds, you'd have a problem. So Databricks rolled out Lakebase, and it still uses similar controls to what we have in the rest of the Databricks platform, but it does answer that OLTP question that's been around for a while, where users may have been writing data that they already had in Databricks back out to a SQL DB or a Postgres or Aurora somewhere else. They now don't have to. They can do it from Lakebase within Databricks itself. It's fully serverless and something that you can definitely just switch on today and start running. It's still very new. So people are still getting used to Lakebase, and we're already then moving on to adding extra features to it with LTAP.
Yeah, and right down to the scaling down to zero, which I think from certainly from an app perspective, that you're not using it all the time, you just shut it down, and then it spins up really, really fast. I noticed.
So yeah, exactly. So Databricks did acquisition a few years ago, a year ago, for a company called Neon, and their DBs have basically were the foundation and what are Lakebase. Super popular just for this scalability. It allows you to really start from scratch, something small that doesn't need to be paying hundreds of pounds for a DB runtime to start experimenting and playing. And that's really means we'll start to see a lot more innovation with tools like Lakebase and, well, new features like serverless micro apps where we can start from zero and we can scale up, and it allows people to innovate without risking budget, really.
Going back to LTAP then, which for everybody is a lake transactional and analytical processing. So it's quite a big claim. Databricks are essentially saying that your lake should handle both operational and analytical workloads without the separate systems. That's just what we were talking about. How realistic though is that for enterprises that we work with today?
Yeah, it's definitely a need our enterprise customers want. They want to be able to work both analytically and transactionally with their data, and this answers that. This allows you to have that lake-based front end, but also have those tables in Unity Catalog. Previously, with the current version, we've had a couple of versions of lake-based so far, a provision one and now an auto-scaling one. The features that have been announced previously that are, I think, still rolling out include a sync to sync those tables back and forth, but you're still then managing another pipeline, potentially another copy of the data in Databricks. And what you really want to do is just have a single copy of the data, but be able to access it both from Lakebase, but also from Unity Catalog directly using your SQL Warehouse, Photon, Reyden, if you'd like. So what this does is, interestingly, sort of under the hood, it's taking any changes made to your PostgreSDB and rewriting them back down to files. So you have just that single copy of the data, but actually it's storing incoming writes in sort of a cache and writing them down. And whenever you do a read, you're reading both the cache and the underlying files. So you can still always check the full state of a table, but you've got it available both in Lakebase and Unity Catalog itself.
I'm going to pick up on an important point you mentioned there, that you only have a single copy of the data. And this, to me, throughout all my work within data, that's always been the utopia. You keep hearing the term single version of the truth. But it has important implications because it means that you're not going to get that stale data problem that you might have if you've got a pipeline running. So how do you think organizations would react to that sort of power?
Yeah, for sure, for sure. There's nothing worse than if you find out that some of the analytics you've been running has been on data that's not fresh or not fresh enough. And with any kind of replication, you have to, it could go wrong. And it's, again, another overhead. So really, this, as well as Lakehouse RT, is about lowering the overhead, allowing these kinds of operations to be very seamless within Databricks. So I think business is going to be excited because they do have that single copy of the data. They do have that low overhead. From the keynote that Holly did at the Data and AI Summit, it looked like it's very seamlessly integrated in the UI, and that it will just appear as a standard table pushed across from Lakebase into Unity Catalog. And you've got the same great features that you have with any other table in Unity Catalog there. Just you'll be able to query it from across both analytical and transactional.
And that's what we want from like an organizational perspective. It's like we don't want to have to try and deal with the numerous different ways and numerous different pipelines to get data that's already in the same platform. We just want to keep it nice and simple. We just want to go, right, I want to access that data, or even from an app perspective, we want that app to be able to read that data really quickly and just respond really quickly. And that, I think that is one of the selling points of Databricks, is you've got that whole ecosystem, lots and lots of open source built into this. but it is also we put lots of these great features in, and we make it really easy for you to use them.
Exactly. It's all about ease of use, making sure that we're not replicating data all over the place, and we can do what we want when we want with our data, and we don't almost have to think about how we're writing down our data. We're just able to read it where we need it. Is that in Databricks apps? Is that directly in Lakebase? Is that in Unity Catalog? Is that in a notebook? We can just read it how we want in a performant manner. So really, it will only need to be select few people who need to know exactly about LTAP and these features, because for most users, the data will just be where they need it as they need it.
So let's have a bit of fun with this. Let's say you've created an app, and it's got a lake-based backend to it, and we want to do some analytics on it. So I don't know, we need to create an idea for an app. I don't know, text-based adventure game. How's that?
For sure. Okay, something I've been doing in-house. Yeah, so we got a text-based adventure game. I've made one recently using the AI, and you've got your text-based adventure. Maybe you want to store back and forth your conversation with the AI, and that needs to be fast, performant. We're going to send our writes in. But let's say I've got 100 people, everyone at Advancing Analytics playing my text-based adventure game. We've got all of their conversation histories, and I want to do an analysis of all those conversation histories. I want to understand where I should be putting guardrails in place, for example, or who's using the app the most, what tokens they're using. We can want to do so much more where we need to aggregate all this data. We can then just use LTAP. We can turn it on as a feature in Lakebase. We'd have access to those tables in Unity, and we can use another engine, so a SQL warehouse, just to aggregate those data, perform complex queries on that data without needing to worry that either we're going to be churning a lot in Lakebase because it's an OLTP engine, or that we need to replicate the data across. It will just be there. And that's sort of the dream, really. As a data engineer, we just almost seamless design, little overhead. One setting I turn on, and the data is where I need it to be, and end users can use it.
And it's not going to have a detrimental effect on those users either. They can carry on playing your text adventure game, and they wouldn't even know anything else was happening with it.
Correct. So it stays up to date. No sort of overhead for them. The only thing I would say at present is we need to see what it looks like at massive scale, in that you probably will have a situation. Well, there may be some scales in which this doesn't rise to meet the demand, but for a lot of use cases, LTAP will definitely be the choice, just for the simplicity and the lack of overhead.
And it'd be interesting to see how this all evolves going forward and into the future. Not only in the Databricks announcements, but also looking at how other organizations and how other people are implementing Lakebase and LTAP in order to meet certain needs. I mean, I always come back whenever I'm thinking streaming, for some reason, I always have weather data in mind. So I'm not quite sure that necessarily fits the use case, but it would just be interesting to see where this goes in the future.
For sure. Currently, operational databases still sit outside of Databricks in many cases. It's whether we rethink about where our data sits and start to bring it all within inside Databricks, even for other areas of the business, such as software engineering, that may not be used to sitting within a Databricks context. They may decide, hey, we don't want to do these handoffs from our software engineering to Databricks. We're using Postgres anyway. Let's spin up a Lakebase, and then we've got that scale. We can integrate directly with our data platform. We don't have to worry about the governance of our data independently of Databricks. We can have our data governance professionals in Databricks also in charge of our operational data. So I would be interested to see, as we move on with this and it matures and we have these features in our hands, whether that allows other areas of the business to start storing their data directly in Databricks, as opposed to these migrations of data inside Databricks, where people are used to more mature technologies or older technologies. We can see perhaps software engineering, other apps within your business landscape start to use Lakebase because it's there, and it's just Postgres. Like, it's not a brand new technology. It very much can be dealt with exactly like any other PostgreDB. So it's pretty exciting. I expect to see uptake of Lakebase increase a lot over the next few years as it matures, but also as businesses start to realize, hey, there's this option here, and this option really cuts out a lot of overhead when I'm dealing with the data analytics function.
Yeah, exactly. It's going to be interesting to see how it works as well with analytics. So historically, in my mind, as we've been talking, for some reason, I just have dashboards in my head. I think I've just been working with Power BI dashboards and AI BI dashboards for far too long. But we're also moving into this world of like Genie spaces, whereby we can interact with this data. Or I should say Genie One as well now, going forward,
Yes, yeah.
where we have these natural language conversations, and then we have that power of it no longer being really, really far behind. It's then much more up to date, almost real time, to have that conversation of how many sales have I done today? And you have that much faster time.
Yeah, exactly. It's having everything in Unity Catalog and sort of increasing sort of the governance, the tagging, the metadata, all with your operational and your analytical tables means that you can answer questions that you perhaps didn't have the ability to previously, or that would require a lot of legwork. One thing that I was at the Databricks meetup in London yesterday that we talked about was the Genie ontology, and that seems to be solving that question too. So by having everything under the same roof and having the metadata and tagging associated with it, we can use tools like Genie One to go, hey, maybe you can answer a question that's a bit more nebulous or like not well defined. And it now has the data from all across the business to potentially work with that. And it would be interesting to see that companies that do adopt this more heavily, whether they do have the ability, therefore, to unlock more value and understanding about stuff that cuts across their entire business because they have all the data in one place.
We won't delve too much into Genie ontology, only because that is a future podcast episode.
Oh, who are
So
you talking to about Genie ontology?
I'll be talking to Ash about Genie
Ah,
ontology. So listeners out there, make sure you download that one when it becomes
I'm looking
available.
forward to it. Yeah, it should be great.
So Lakehouse RT, it promises this millisecond latency at scale without making all those copies of the data, as we said. But if you're a team and you spend years of your life developing ETL or ELT pipelines specifically to feed separate real-time serving layers, what does this actually mean for them for how they architect things going forward?
So, like everything, this is a change. You have to stay ahead of the curve. Like, it does mean that those pipelines, as you move to using Lakehouse RT, may not be needed anymore. And that's really an upside. That means you can work to deliver other areas of value, things that lower down on the priority list that you've not been able to get to. You can tick off the or cross out the overhead of looking after when those pipelines break, when are you keeping those other databases up to date, and you can go back to working on other areas of Databricks where you've not been able to get to it yet. So it does mean those pipelines will go away, but really that's an exciting thing that opens up more time for you as an engineering team to be able to develop more business value than just replicating your data somewhere else. That should be an easy transfer to using Lakehouse RT, which means then people can read those tables that you've already replicated, but just directly from Databricks at the speed they need. And that reporting, therefore, will not have to change significantly. So there'll be migration work in the medium term as you transfer from whatever database you're using over to Lakehouse RT. And then the longer term, that frees up capacity to not have that overhead and to be able to do what your team really can do to provide extra value, whether that's ingesting new data sources, improving how Genie One is working or Genie agents. Really, it's an exciting time as that overhead comes down for your team.
Okay, so lastly, and this might be a tricky one, which one are you looking forward to most? Lakehouse RT or LTAP?
Oh, that is a tricky one. I'm more interested in LTAP, I think. I think there are slightly more use cases where I have customers who have these operational DBs that they want to see in analytics than I do have customers at the scale where they'll benefit from Reyden and Lakehouse RT. So I'm interested in LTAP personally, but both will be exciting. I can't wait till they get out of beta and sort of into our hands, and then we can get them into our clients.
And the speed that Databricks work, hopefully that will be very soon. Everything is
Oh yeah, I'm sure by the time this comes out, it'll already be there.
all fingers and toes are crossed that they can speed these ones through. That's brilliant. Thanks, Peter. We will see you again on the Data Hot Seat soon, hopefully. But in
Perfect.
the meantime, I will say see you later.
Cheers, Paul.
And that's a wrap on today's episode of the Data Hot Seat. Thank you to Peter for taking us through Lakehouse RT and LTAP. What strikes me most about this one is how much architectural simplification is on the table here. For years, teams have accepted that real-time and analytical workloads just need separate systems, separate pipelines, separate governance, separate everything. If Lakehouse RT genuinely delivers on that promise, that's not just a performance story, it's a how many systems can we retire story. If today's episode was useful, share it with someone on your team who will find it just as good. And if you've got thoughts on anything we've discussed today, we'd love to hear from you. From all of us here at Advancing Analytics, we'll see you next time. The Data Hot Seat.